So today we're going to cover lesson 4, and we're going to learn how to graph these polynomial functions that aren't going to be linear. They're not going to be just normal cubic functions. They're going to have an end behavior. So let's go ahead and see what an end behavior is. So when our exponent is an even number, the end behavior is going to simulate the same as an x squared graph. So remember, the x squared graph was the parabola. So the end behavior of a polynomial that has an even exponent as the largest exponent, and it's a positive number in front of that even exponent, would go like this. If it's a negative number or a negative sign, the end behavior is going to be going down. If it's an odd exponent, then the end behavior, it'll go down and up or up and down. So again, that's similar to the x cubed function, which look like this. So again, what we're doing is taking these ends, and that's what's going to be put on our graphs. So for example, if I have an x to the 5th power, notice 5 is an odd number, so my behavior for an odd function would be down and up. And this is what I'm going to attach to the zeros that are on the ends. And then I'm going to choose points in between. So these are going to be the steps that we're going to follow in order to graph a polynomial function. So the first thing we need to do is to find the zeros. And you're going to need to find those zeros by either factoring or synthetic division. Most of these are going to be greater than an exponent of 2, so you're going to have to do synthetic division first to find one of the zeros before you can bring down your power and turn it into a quadratic equation. Then after we find the zeros and plot them along the x-axis, then we're going to also add in our end behavior. We're also going to find the y-intercept. We're going to address any multiplicity of any of our solutions. Multiplicity is going to be the number of times an answer occurs. Whenever it occurs, like 2 times, it's going to create a bounce. If it only occurs once, it's going to go through the x-axis. Then the next thing we're going to do is we're also going to find additional points in between the zeros. And we can use our remainder theorem, or you could just plug in your values of x into the function. Either way. So again, this is multiplicity. And multiplicity is just the number of times a factor is going to occur. So for example, if you have y equals x minus 1 squared, once I solve this, I know that I'm going to get x minus 1 equals 0. So my solution of x equals 1 is going to occur 2 times. So this would have a multiplicity of 2. Now, all of these in this one, notice each one is only represented 1 time. 1 is an odd number. This has a multiplicity that's odd, and it's going to run through the x-axis. So, for example, if I take this one, let me go ahead and add it down here. So the x minus 1, the x plus 2, the x minus 3. If I solve all of these and find out where my x-intercepts are, I get positive 1, negative 2, positive 3. So what this tells me is that at 1, I have a 0. At 3, I have a 0. And at negative 2, I have a 0. So when it's got a multiplicity that's odd, it's going to cross through the x-axis. If I had x minus 3 twice, then what would happen here is I would get x equals 3 2 times. And what would happen is it would come down here, hit it, and bounce back up. or if it was coming in from this direction, it would be like a bounce or a touch and turn. And we're going to see this as we graph them. So let's go ahead and try our first example. So what I need to do here is I need to find my zeros. So this is the same thing that we did last night. So again, if you want to list your possible zeros, the factors of negative 15, plus and minus 1, plus and minus 3, plus and minus 5, plus and minus 15. Now, what you can do, so you don't have to go through 8 different possibilities here, you could key that in your calculator to figure out which one of those numbers works. Okay? I already did it ahead of time. 3 is the one that works. So I'm going to go ahead and do my synthetic division. I'm going to take my coefficients, the 1, the 3, the negative 13, and the negative 15. Remember, I need to get this to a quadratic equation that I can either factor, solve by completing the square, or quadratic formula. So I'm going to drop down the 1. I'm going to multiply, add, multiply, add, multiply. I got a remainder of 0. Okay? Now again, you can key this in your calculator to find that 3 is the one that crosses the x-axis out of this list. Now that I can add my variables back in. Remainder, constant, x squared. So I have x squared plus 6x plus 5. I now have a quadratic formula or equation that I can either solve by quadratic formula, completing the square, or factoring. Again, if I can factor something, that is usually the fastest way. So I'm going to factor this into x plus 1 and x plus 5. Set each of the factors equal to 0. Solve for x. So I have a 0 at negative 1 and negative 5. And the 3 from the beginning. These are my 3 zeros. Notice the exponent up here is a 3. Now, my end behavior of the x cubed, remember that's going to be, it's odd, down and up. So let's go ahead and graph these 3 zeros along the x-axis. So I'm going to graph 1 at negative 1, 1 at positive 3, and 1 at negative 5. I can add in my end behavior. It's down and up. Now what I need to do to fill in between those 2 zeros is I need to find a point in here and a point in here. So again, you can either plug in values of x into the function, or you can use the remainder theorem and use synthetic division. Either way. I'm going to do synthetic division. So for this first section, let me erase this. So for a point that's in the red section, I'm actually going to plug in negative 3. Okay, because negative 3 is right here. So I'm going to plug in negative 3. I'm going to do a synthetic division problem to get how high or how low the order pair is going to be. So 1, 3, negative 13, and negative 15. Drop down the 1, multiply, multiply, and 39, and 24. Oops, not 29, 24. So my order pair that I'm going to graph is negative 3, 24. I also need to find a point in between these 2 zeros. All right, so I'm going to pick a number in between there. Now, really, I could just use my y-intercept. That's the easiest. So let me go ahead and just get my y-intercept, and I could go back to my original equation for that. So if I plug in 0 to get my y-intercept, it's going to be at negative 15. Are you with me on that? You plug in 0 for x. So my other order pair, that's going to be in that green section, is going to be the order pair 0, negative 15. Now, let's say you wanted one other one besides the y-intercept. Let's go ahead and do a synthetic division problem, and let's put in a 1. So 1, 3, negative 13, negative 15. Drop it down. 4, negative 9, negative 24. So now I have another order pair that I could also graph. So let's go ahead and graph those. Let me erase this. And again, probably I won't give you a coordinate grid because some of these order pairs are going to be super huge. This is why I want you to play around with your calculators, because some of these numbers are going to go off of your grid. The standard grid is 10 by 10. You're going to need to be able to zoom in and out on your calculator to find these zeros. So you need to know how to use this expensive tool that you've spent a lot of money on. If you're not going to take the time to learn how to use it, you're wasting your money and your time. Okay, so let me go ahead and graph these order pairs. So 3 and positive 24. I'll just say it's negative 3, 1, 2, 3. Let's just say it's up here. Negative 3, 24. So I go from this point, the 0, up to here. Then what I'm going to do is when I come back down, I had a 0 here at negative 1. So then he comes back down, hits the 0. I'm also going to hit my y-intercept. I'm just going to say that this is the order pair 0, negative 15. So he'll come in here, hit that. And then the next one would be the negative 24. So I'll go a little bit lower. So we'll say that's about 1 and negative 24. And then back up to connect with the end behavior. So that would be your graph of that polynomial. Here's another one. This one's already factored for us. Now, notice for my end behavior, I'm not just looking at the x squared. I got to count how many x's I have. And I actually have 4 x's here. So this is going to be an end behavior of an x to the 4th, which means the ends are going to go up. So I have a 0 at x equals 0 because I'm solving x squared equals 0. So I have 2 of them at 0. I have x equals negative 1 and x equals positive 1. For this one, it's going to be a bounce. So let me go ahead and put these zeros on my graph. So I have one at negative 1, 0, and positive 1. So now my end behavior, I can add that in. Remember, it was x cubed, so I can just add the up arrows on both. So what I need to find now is an additional point between this 0 and this 0, and then 1 over here. Notice I'm looking for a number between negative 1 and 0, and then another number between 0 and 1. So I have to plug in a fraction. So let me go back to my original problem. I'm just going to use the factored form. So I'm going to plug in, I'm going to find negative half, x equals negative half, and then I'm going to plug in x equals 1/2. So if I take my original, I get negative 1/2 squared, 1/2, negative 1/2 plus 1, negative 1/2 minus 1. This gives me 1/4. This gives me 1/2. This gives me negative 3/2. This gives me negative 3 over 16. I'm going to do the same thing for the positive half. square it. I'm going to add it. I'm going to subtract 1. So I get 1/4, 3/2, -1/2. I still get the same y value. So now I'm going to graph these two order pairs, the +1/2 and the -3/16 and the -1/2 and the -3/16. So when I'm doing this, I'm only dipping it down like very so slightly. So remember, the 0 had a multiplicity of 2. So what's happening here is, let's say this is the point I'm trying to graph. Let's say this is the point -1/2, -3/16. I'm coming down here. I'm hitting the 0. I'm not crossing the x-axis because it had a multiplicity of 2. It's hitting the 0 and bouncing back down and then making like a little loop there. So when your 0 occurs more than once, especially if it occurs 2 times, it's like a bounce. It'll touch it and then go back down again. Or if it's on the top side, it would touch it and turn. Let's try another one. Last one, that was 4.
Oh, okay. Thank you.
Okay, notice this time I didn't give a grid because again, my graph looks kind of crazy. My numbers are going to be super high. So again, it's already factored for me. So I can see my zeros here. I have x equals 0 twice. I have x equals 5, x equals -3, and x equals 1. My multiplicity, let's count how many x's we have. We have 2, 3, 4, 5. My end behavior is based on x to the 5th. So it's going to be down and up. So let me go ahead and graph these 5 zeros. And again, one of them repeats, so I'm only really placing 4 points on my x-axis. So I'm going to put in -3.
So you put x equals 0.
Yes. So I have one here at -3, one at 0, one at 1, and one at 5, because 0 is twice. I can add in my end behavior, so it goes down and up. To figure out how it wiggles in the middle, I need to find a point in between these two zeros. I need to find a point in between these two zeros, and then a point in between these two zeros. Now, if you're using your calculator, you're going to hit the second key and the graph button and get the table of order pairs. Otherwise, you're going to do it by hand by plugging it in. Yes?
If it's x squared, why would it be the square down and up? Wouldn't it be both sides?
Okay, so you have to count how many x's you have. So I have an x,
Oh, okay.
you see that? So there's actually 5 x's there.
Thank you.
So when it's already factored, be careful on those. Count how many x's are there. If it's not factored, then you would just look at the biggest exponent.
And then the last one was 3.
Okay.
What would we put in the table?
So let's plug them in. So in the green section, I could plug in -1, I could plug in -2, and then get another point. I'm going to plug in -2. I'm just going to use the factored form. So I'm going to find f of -2. So I'm going to do -2 squared, -2 minus 5, -2 plus 3, -2 minus 1. So 4 times -7 times 1 times -3. And this gives me positive 84. So when I go to graph this, I'm going to go to -2 and then positive 84. Let's just say it's right here. So So let's say this order pair is -2, +84. Now I need to find one in the yellow section. So notice that my 0 there is at 1, so I'd have to plug in like a half. So let's see. So if I plug in +½ I would get 1/2 squared, 1/2 -5, 1/2 +3, 1/2 -1. So 1/4, -4.5, and then 3, 3.5, and then -½ So when I multiply fractions, I need to make them improper. This will become 9/2, 7/2. Nothing simplifies here. So I'm going to get 63 over 2 times 2 is 4, 8, 63 over 32. So not quite 2. So this would be 1 and 31 over 32. Almost to the 2. So when I go to graph this, this would be the order pair I would graph. And now I need a point in this gray section. So I'll plug in 3. So 3 squared. And then I'll do 3 minus 5, 3 plus 3, 3 minus 1. So 9 times -2 times 6 times 2. And this will give me -324. All right, so let's go ahead and plot these points. So from here, I'm going to come down to the 0. Remember, 0 was twice. I'm not cutting through. I'm bouncing. And I'm going to bounce back up to about 2. And then come back down. And then go down here. And then back up to my end behavior. So this could be the order pair I just found. At the 3, -324. This could be the 1/2, comma, 1 and 31 over 32. So you need to find additional points in between each one of the zeros. Catch Vincent, this should be -216. Let's erase that. So -216. Okay. So for this last one, notice my last term here. It's 36. So if you were doing this question for homework, you're going to have all of these possible zeros. Plus and minus 1, plus and minus 2, 3, 4, 6, 9, 18, 36. Oh, I forgot 12. So 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. That's a bunch of zeros that I might have to potentially check. So instead, I recommend you key that in your calculator to figure out which one of these is actually the 0. So that way you don't have to do 10 different problems until you finally come to the one that works.
1 of them is -1.
Okay?
And I think -6.
Okay? +6 is going to be one of them. So let's try that. So I'm going to do +6, and I'm going to do synthetic division. Once I get it into synthetic division, then what I can do is turn it into a quadratic and either factor it, complete the square, or quadratic formula. So 1, 1, -36, -36. Drop down the 1, multiply, multiply. So x equals 6 is one of my zeros. I now have a quadratic equation. So I have x squared plus 7x plus 6. Luckily, this can be factored. So 2 more zeros are x plus, or 2 more factors are x plus 1 and x plus 6. So the other 2 zeros are x equals -1 and x equals -6. I'm going to go ahead and graph those on my x-axis. So I'm going to put 1 at -1, 1 at -6, 1 at +6. Let me go back and look for my end behavior. My end behavior is x cubed. So I know it's going to be down and up. So let me add that to these end zeros. So now what I need to do is find an additional point in between this 0 and in between these 2 zeros. And then I'll know how it wiggles in between. Now, I could find my y-intercept as one of the zeros. That's something you should always graph anyways. So that's going to be 0, -36. To find my other point in between the -1 and the -6, I'm going to do synthetic division.
The y-intercept is -36.
Yep. So I'm going to do -3 for the point in the green section. So 1, 1, -36, -36. I'm going to drop it down, multiply, multiply, and then I get 90, and then 90 minus 36, 54. So I'm going to graph the order pair -3, comma 54. So I would come up here and then come down. So I would say this could be -3, comma 54. I'm going to come down, hit my y-intercept. I'm going to pick another point in that blue section. I'm going to plug in, let's plug in 2. So let's do synthetic division. 1, 1, -36, -36. Now, keep in mind, to get these additional points, if you keep this function in your calculator, you hit second and graph, and it produces the table of order pairs. So you don't have to do these calculations by hand, okay? And again, your quiz is going to be calculator, but be able to do this by hand on an SAT. So let's go ahead and bring this down. Multiply, multiply, -60, and I get -96. So then this one's going to come down a little bit lower and then eventually catch up. Homework is 21 through 41 odd. The beginning part is just giving me end behavior.